Welcome to Astronomy Daily, your interstellar pass to the wonders stretching across the infinite canvas above us. This is Season 3, Episode 12, and together we're about to delve into the most captivating stories from the frontiers of space exploration and cosmic discovery. So, whether you're a seasoned stargazer or a curious cosmophile, buckle up. Our celestial safari through the cosmos begins now. Stay tuned. There are marvels aplenty ahead.
The Astronomy Daily Podcast.
Space enthusiasts and cosmic voyagers, have you caught the latest buzz from SpaceX? Their mighty behemoth, the Starship, touted as the world's most powerful rocket, has once again etched its journey into the annals of space exploration. Amid the crackle of anticipation and a spectacle for the eyes, Starship ignited its engines and soared into the sky, further and faster than in its previous escapades. Launching from Starbase in Boca Chica, Texas, precisely at 8:25 in the morning local time, the flight was a symphony of raw power and engineering prowess, streamed live to millions, holding their breath across the folds of the internet. As it pierced the heavens, Starship wasn't just carrying the dreams of SpaceX, it bore the aspirations of humanity, playing a pivotal role in NASA's audacious plans to return astronauts to the lunar surface and, dare we imagine, Elon Musk's vision to dot the red sands of Mars with the footprints of colonists. But space, with all its allure, remains untamed, reminding us that triumph and turbulence often dance in a tight embrace. As Starship blazed through the atmosphere, the mission encountered adversity during re-entry over the Indian Ocean. Signals fell silent and Starship was declared lost, likely succumbing to its fiery descent, leaving behind a trail of the unknown and an investigation labelled a mishap by the Federal Aviation Administration. This event doesn't eclipse the collective cheer that broke out as Starship met many objectives along its journey, opening its payload doors in a nod to future satellite missions, gracefully re-entering our planet's atmospheric caress. These were moments of accomplishment. Even as SpaceX's Super Heavy booster couldn't quite stick its water landing, we're reminded of the relentless spirit of innovation that propels them forward. So, where does this bring us, you might ask? The rapid iteration and real-world testing, the DNA of SpaceX methodology, these are the stepping stones to greater leaps. The Falcon 9s, the Dragons, and the Starlink constellations are testaments to this approach. And though competitors may loom in the rearview mirror, like China with its own lunar aspirations, the race to celestial bodies is far from over. The story of Starship is one of human grit and the unyielding quest to reach beyond our earthly cradle. With each test, with each launch, we learn, we adapt, and most importantly, we dare to dream of futures once penned only in the fabric of science fiction. Stay with us as we keep our telescopes trained on the horizon and our hearts set amongst the stars. In a revelation as icy as it is illuminating, the James Webb Space Telescope, humanity's premier eye in the sky, has peered into the cradles of starbirth, unveiling a cosmic tapestry strewn with icy molecules. These observations are not just any discovery. They strike at the core of one of science's most profound questions. How did life begin? Picture this. Two infant stars, known as protostars, embedded within their natal cocoons of gas and dust. It is within these swirling celestial nurseries that Webb's keen vision has spotted the frozen seeds of our existence. From the simplest of molecules like methane to the more complex acetic acid and even ethanol, yes, the very essence of your favorite tipple, the diversity is staggering. This is more than just a chemical inventory. It's a snapshot of the early stages of a planetary system. Think of it for a moment, a solar system in the making, much like our own was over 4.6 billion years ago. It's here, around the low-mass protostar Iris 2A, that these ices present a narrative link to our primeval solar soup. And what's more intriguing? These findings bolster the idea that the building blocks of life, the complex organic molecules we find essential, may already be in formation even before planets begin to form. It brings us a step closer to understanding the cosmic lineage of life's genesis, from the icy confines of space right to our doorstep. The chemistry is captivating in its own right. We have methyl formate, the precursor to formic acid, and even acetaldehyde. Complex organic molecules, or COMs, that were previously just theoretical musings or lab-bound concoctions are out there in space, and they're not just confined to gas form. Their icy incarnations are like chemical messages, penned in the language of the cosmos, awaiting our interpretation. Now, some might wonder, how did these molecules come to be? We owe that to the serendipitous interactions on the surfaces of dust grains, cold yet bustling microcosmic labs where these molecules are cobbled together. This intricate dance of atoms in the void is what sets the stage for the richness of chemistry that life, as we know, demands. The discovery of these icy chemical storehouses around protostars gives credence to the theory that comets and asteroids may be the cosmic vessels that delivered these vital ingredients to burgeoning planets. Imagine comets not merely as celestial wanderers, but as interplanetary couriers, ferrying the potential for life across the vastness of space. The James Webb Space Telescope continues to unravel the cosmic quilt, one thread at a time, reminding us that life's beginnings may be written in the stars, frozen in time and space, waiting for the warmth of new suns to awaken the potential etched within their icy folds. In the vast cosmic arena, our understanding of supermassive black holes has been tantalizingly mysterious. Until now. Thanks to the extraordinary vision of the James Webb Space Telescope, astronomers have spotted a series of faint little red dots in a slice of the sky, and these spots could be the keys to unlocking secrets as weighty as the black holes themselves. What are these red dots, you might wonder? It turns out that they are not just any ordinary distant galaxies, but they may very well be the infant stages of the behemoth black holes that leave us both perplexed and amazed. With the ability to peer back in time, JWST has detected that these red specks are, in fact, small versions of the extremely massive black holes we call quasars. Picture this. The light from these quasars and little red dots has been travelling for billions of years before reaching us. It's a journey across time, bringing us snapshots of the universe's history. Now, while the monstrous quasars are brilliant and blue, these little red dots are dusty red and only a fraction of the size. Yet, they carry in their cores black holes that are growing, a nursery of cosmic giants, if you will. And why does this matter? Well, some quasars ought not to exist. They're too massive, having grown inexplicably large in the universe's youth, a conundrum that has left astronomers scratching their heads. It's as if observing a 5-year-old the size of an NBA center. Current theories say there just hasn't been enough time since the Big Bang for them to get so big. But with the discovery of these little red dots, this notion is now challenged. Perhaps these are the baby quasars that will grow into those problematic giants, granting us insights into their unexpected rapid growth. What's crucial here is the H-alpha spectral emission lines detected by JWST's near-infrared camera. They reveal that these dots harbour massive objects and suggest the presence of primitive black holes 100 to 1,000 times smaller than the puzzlingly overweight quasars. Our future may now hold a deeper understanding of these gargantuan features at the hearts of galaxies. How did they come to be? How did they grow so vast? The clues hidden within these little red dots observed by JWST may help us answer these burning questions, lifting one of the greatest veils of mystery about the cosmos. So, as we gaze up at the night sky, let's reflect on the fact that in every tiny dot could lie the beginnings of nature's most profound titans, supermassive black holes with gravity so strong not even light dares escape their pull. With JWST's continued scrutiny, the genesis of these space-time warping behemoths is finally within our sights. Stay with us on this remarkable journey through space and time as we continue to track the evolution of these celestial wonders and keep pushing the boundaries of what we know about the universe. The Winchcombe meteorite, a cosmic messenger from the very birth of our solar system, has provided scientists with a real-life space detective story. This carbonaceous meteorite, which painted a fiery streak across the UK skies in February 2021, holds within it the chemical and molecular fingerprints of our primordial celestial neighbourhood. Within just hours of its landing, researchers feverishly collected samples, eager to study them before Earth's environment could sully its pristine condition. These weren't any ordinary space pebbles. They were rich in carbon and nitrogen, the very stuff that gave rise to water and organic molecules on our fledgling planet. Using advanced microscopes, scientists embarked on a journey not through space, but within the nanocosmos of the Winchcombe itself. Their quest? To uncover the roles these meteorites played in the delivery of life's building blocks to Earth. And what they found was nothing short of revolutionary. Zooming in at a level of detail that would make any microscope blush, the research team discovered nitrogen-bearing molecules, the kind that form the backbone of amino acids and nucleobases. We're talking about the fundamental components of proteins and DNA, the cornerstones of life as we know it. The analysis was arduous, employing cutting-edge techniques like synchrotron radiation alongside some of the most powerful electron microscopes. This synergy allowed the team to detect biorelevant molecules with such precision that it has never been done before. The Winchcombe meteorite retained these extraterrestrial organic molecules, which suggest, quite tantalizingly, they could have been the spark that ignited the flame of life on ancient Earth. The discovery offers a tantalizing possibility. Could the Winchcombe meteorite be a time capsule, holding the secrets of our biological ancestry? Was the evolution of life on our home world written in the stars, delivered to us by way of interstellar post? So, the next time you gaze up at the night sky, remember the Winchcombe meteorite. As it turned out, this unassuming chunk of rock wasn't just another piece of the cosmic puzzle, it was a veritable Rosetta Stone, unlocking the origins of life on our pale blue dot floating in a sunbeam. And thanks to the tenacity and ingenuity of our scientists, we're one step closer to understanding our place in the cosmos. What a time to be alive! With neutrinos whizzing through the cosmos, passing through everything in their path, including us, it's no surprise they've earned the eerie moniker ghost particles. These elusive messengers hold secrets to the most violent and energetic events in the universe, from supernovae to colliding neutron stars, and unlocking these secrets has been a monumental challenge for astrophysicists. But a breakthrough has come from a place as silent and isolated as the space from which these particles travel, the icy desolation of the South Pole. Here, entombed in the frozen expanse, lies the Ice Cube Observatory, a marvel of modern science. Its golden-eyed detectors, digital optical modules or DOMs, lie dormant and patient within the Antarctic ice sheet, waiting to capture the faint glimmers of blue light produced when neutrinos interact with molecules in the ice. And after a decade of sifting through a glacial amount of data, IceCube is shedding light on these cosmic spectra with new findings that feel like decoding whispers from the edge of the Milky Way. Scientists have isolated signals from 7 candidate astrophysical tau neutrinos, one of the 3 flavors in which neutrinos manifest. Tau neutrinos are particularly noteworthy not only because of their scarcity, but also because their detection paves the way towards a better understanding of the high-energy processes that take place in the far reaches of space. Determining the origins and interactions of tau neutrinos could answer profound questions about high-energy celestial events and the fundamental forces shaping our universe. The team at IceCube didn't rely solely on manual analysis for this feat. Instead, they turned to the powerful capabilities of image classification-optimized convolutional neural networks. These artificial intelligences combed through nearly a decade of detailed IceCube data to hunt for the faint but distinctive signatures left by tau neutrinos. This advanced approach may look like it's straight out of science fiction, but the results are very real, potentially leading us to an entirely new understanding of neutrino oscillations, a phenomenon where neutrinos switch flavors as they traverse the cosmos. These ghostly particles could finally start revealing their secrets, ushering in an era where we don't just gaze up at the night sky and wonder, but also listen intently to the messages it sends us through these tiny, almost undetectable messengers. In essence, IceCube is not just a detector, but a key to a door that has long remained shut, a portal to understanding the high-energy physics of the universe. And with more data, more analysis, and the kind of insatiable curiosity that has always driven humanity skyward, we stand on the brink of piercing the shadows of the cosmic unknown. With IceCube's findings, we might soon grasp the ethereal tales spun in the silent space dance of neutrinos. tales of origins, of cataclysms, and of the immense energy changing the fabric of existence far beyond our blue home. And that's a journey around the cosmos from the comfort of your own headphones, folks. From SpaceX's stellar ambitions to the icy chemical symphony witnessed by the Webb telescope and the head-spinning discovery of ghost particles dancing through the poles, we've covered some astounding celestial ground today. But as vast as the universe is, there's always more to marvel at. So don't let the adventure end here. Grasp the stars by heading over to astronomydaily.io. That's astronomydaily.io. There you can catch up on past episodes and subscribe to our free daily newsletter, ensuring a steady stream of the universe's wonders is always just a click away. Remember to subscribe so you never miss out on the wonders and mysteries awaiting us in the ever-expanding universe. Until next time, keep your eyes on the skies and join us again for another episode of Astronomy Daily, the podcast. Signing off and wishing you clear skies.
The Astronomy Daily Podcast.